Welcome to the dojo. Think of this explainer as your ultimate mathematical martial arts training ground, specifically designed to help you absolutely crush your Cambridge Additional Mathematics 0606 exams. Listen, the core concept we are mastering today is simple but incredibly profound. Flow like water. You need to be able to adapt your mathematical style to any single question that the examiners throw your way. Today, we are unlocking the secrets to mastering absolute value functions. Specifically, the tricky relationship between y equals f of x and y equals the absolute value of f of x. Whether we are talking about linear, quadratic, cubic, or crazy trigonometric functions, mastering this relationship is absolutely essential for your Cambridge success. It is a topic that appears without fail in literally every single examination series. They love testing it. So I am here as your strategist to show you exactly what senior examiners are looking for, how to systematically secure every single method mark, and how to build an absolutely bulletproof exam strategy that flows naturally under pressure. Let's get right into it.
Okay, so let's dive into this massive question right out of the gate, because this specific topic trips up literally thousands of students every single year across syllabuses like 0580 and 0606. Why is it so incredibly hard to apply absolute value concepts to unfamiliar contexts? Well, to understand this, I want you to picture two typical students sitting in the exam hall. Let's call them Alex and Sam. First, we have Alex. Now, Alex is the kind of student who overloads their brain and their exam paper with raw mathematical facts. They've memorized every formula, they know the rigid rules, but they apply absolutely zero critical analysis. When a question asks to sketch the graph of a transformed quadratic function, Alex just starts drawing straight lines and parabolas everywhere without ever explaining or restricting the domain. It's just a mess of ink, and the examiner pulls out the red pen. Then we have Sam. Sam is a completely different story. Sam looks at the clock, starts rushing, sees those two little vertical absolute value brackets, absolutely panics, and completely misses the command word requirements in the prompt. Sam tries to solve an equation when the command word clearly said sketch. Both of these students are failing to flow like water. They are fighting the question instead of adapting their style to what the examiner actually wants. And the result? Red marks all over their papers.
So how do we fix this? It starts with deeply understanding the underlying theory, whether you're dealing with a simple straight line, a parabolic quadratic curve, an S-shaped cubic, or a wildly complex trigonometric wave. The theoretical architecture here rests on understanding precise definitions and causal relationships. The fundamental principle of y equals the absolute value of f of x is that the modulus operator forces all output values to be non-negative, meaning any part of the original graph of f of x that dips strictly below the x-axis, where the y values are negative, is physically reflected above it. It's like the x-axis is a mirror, and the negative portion just bounces right off it. But here's the critical part, and where Alex and Sam go wrong. It's not just about loosely drawing a V-shape or bouncing a curve off an axis. It is about understanding exactly mathematically why that happens, pinpointing the exact coordinates where that reflection begins and ends, and communicating that systematically to the examiner. You have to know the precise roots where the function equals 0, because those roots are the exact pivot points for your reflection, regardless of the function family you are dealing with.
Now, what's really fascinating here is an insider secret straight from the examiners themselves. The principal examiner reports for these subjects consistently highlight that integrating this absolute value topic with other syllabus areas is the absolute key to top-tier scores. We see this across the board, from the 4024 and 4037 syllabuses right through to the 4040. For example, if you are graphing the absolute value of a trigonometric function, you aren't just doing absolute values in a vacuum. You are applying your knowledge of amplitude, period, and phase shifts all at the exact same time. If you are solving an inequality involving a modulus quadratic, you are actively linking coordinate geometry with complex algebraic inequalities. These cross-topic connections show the examiner that you don't just memorize isolated chapters from a textbook. It proves that you understand the entire interconnected landscape of mathematics. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, building these cross-topic connections is exactly what we train you to do.
You see, the exam isn't just a test of your memory. It's practically a psychological evaluation targeting 3 distinct cognitive domains to see exactly how you process mathematical relationships under pressure. First, they test knowledge and understanding. Do you actually know what those vertical bars fundamentally mean? Second, application. Can you apply this reflection principle to a bizarre, complex cubic function that you've never seen before in your life? And third, analysis. Can you successfully decode the command words? This is exactly where top students utilize what we call the PEAL framework. That stands for point, evidence, explanation, and link.
Let's say you're asked to describe a modulus transformation. Your point is stating that a reflection has occurred. Your evidence is identifying the specific mathematical domain, for example, noting that x is between -2 and +4. Your explanation details exactly how the y values change from negative to positive, and finally, your link connects everything back to the original fx function. It's a foolproof, standardized way to ensure you never miss a required element in your response.
Section 1, the Procedural Framework Blueprint. Let's shift gears and look at the actual step-by-step success blueprint that completely separates the students who freeze up from those who smoothly flow through the entire problem.
The most crucial concept you need to internalize right now is what we call the method mark strategy. What does this actually mean for you in the exam hall? It means your systematic processing is what actually secures the points, not just perfectly guessing the final answer. Let's look back at our student Sam. Sam rushed to the final answer on a tricky modulus question, made a tiny arithmetic error, got the final coordinate wrong, and scored an absolute 0. Why? Because there was literally no working out shown. Zero evidence of analytical thought. The tragedy here is that even if your final sketched graph of y equals the modulus of a cubic function is slightly sloppy, you can actually secure the vast majority of the method marks by explicitly showing your coordinate calculations, clearly stating your vertices, and mathematically demonstrating that you know the portion below the x-axis must be reflected. The examiner wants to reward your logic. You have to give them the evidence to do so.
By systematically applying this 5-step sequence, the scattered, panicked answers we saw earlier from Alex and Sam instantly transform into precise, full-mark responses. Let's walk through it. Step 1. Identify key elements. Before you draw anything, where exactly does the original fx graph cross the x-axis? You need those roots. Step 2. Apply relevant principles. Remind yourself that the modulus only affects negative y values. Positive y values remain completely untouched. Step 3. Execute your analysis with clear working. This is your Peel framework in action. Show the algebra. Step 4. Verify your results. This is a game changer. Pick a random x value, plug it back into your original absolute value equation, and see if the y value matches your sketch. It takes 5 seconds and prevents massive errors. Finally, Step 5. Present in the appropriate format. Are your axes labeled? Have you drawn a smooth curve or a sharp vertex where appropriate?
And speaking of formatting, you absolutely cannot just stop at the math. Your presentation of that mathematical information must follow strict conventions to completely satisfy the examiners. You must use clear, undeniable annotations on your sketches. If the question asks for the relationship between y equals f of x and y equals absolute value of f of x, your graph must have any asymptotes clearly labeled with dashed lines and equations. The x and y intercepts must be explicitly marked with coordinate pairs, and you must use the correct terminology. Please never write that it's a flipped line. Use precise mathematical vocabulary. Write something like, it is a reflection of the curve in the x-axis for all values where f of x is less than 0. This level of precision is exactly what pushes you up an entire grade boundary. Stop scrolling. Subscribe to our YouTube channel ACE Exams at ACE_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @ACEXams_IGCSU and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 2. Evaluation and Critical Analysis. Now we reach the evaluative stage, which is where we tackle those really tricky higher-order assessment objectives that separate the A-star students from the rest.
All right, we are going to do a quick interactive workshop right now to test your skills. I want you to imagine a 60-second timer ticking down in your head. You need to elevate your problem solving from merely describing what you did to analytically evaluating your approach. Challenge 1, data scan. When you look at a complex absolute value graph, can you immediately, within seconds, spot the critical points? Can you extract the core trend of the slopes? Challenge 2, find the flaw. Listen to this flawed descriptive paragraph from a past paper attempt. To graph the modulus of this quadratic, I drew a U-shape, and then I took the bottom part and put it on top because absolute values make everything positive. Did you spot the massive flaw? It uses terrible terminology and gets 0 method marks. Now, challenge 3, speed writing. How do we fix it using an evaluative approach? It sounds like this. I evaluated the roots of the quadratic equation to determine the specific domain where f of x is less than 0. I then applied a reflection across the x-axis exclusively to that interval, justifying the resulting sharp, non-differentiable points at the x-intercepts. Boom! See the difference? That right there is examiner commentary gold. Furthermore, when the command word explicitly asks you to compare two functions, you must remember to use comparative connectives. and support every single claim with hard, undeniable mathematical evidence. Comparative analysis strictly requires identifying similarities and differences. For example, let's look at y equals f of x versus its modulus. A similarity? Well, the domain usually remains exactly the same. The allowable x values haven't changed. The y-intercept might even be exactly the same if it was already a positive value. But a key difference: the range completely changes. The original linear function might have a range of all real numbers, going from negative infinity to positive infinity. But the absolute value function's range is restricted strictly to y is greater than or equal to 0. Highlighting these specific, mathematically proven similarities and differences is how you drain every single available mark from the paper.
Section 3. Avoiding common exam traps. Let's pivot to some serious warnings directly from the principal examiner reports so you can avoid losing easy, silly marks.
The examiners have meticulously analyzed thousands of papers, and they see the exact same tragic errors repeating cycle after cycle. These are the top 3 documented mistakes students make under intense time pressure. Number 1, using the wrong approach for the wrong context. This is the classic trap. You might try to solve a complex cubic absolute value equation using an analytical method meant for simple linear inequalities. It just doesn't work. Number 2, forgetting to check format and presentation. You do all the incredibly hard algebraic work, but you completely forget to label the x and y axes on your sketch, instantly losing a crucial presentation mark. Number 3, answers are not specific to the context given. If the question gives you a specific trigonometric domain like 0 to 2 pi and you provide a general infinite solution, you lose marks. This is precisely where our time management matrix comes in. You must allocate your effort based on the marks. Don't spend 10 minutes meticulously plotting individual points for a 2-mark sketch question, and please don't rush through a 6-mark critical analysis paragraph. Let the method marks dictate your time investment.
This next point is a massive red flag directly from the examiners. You must always define your mathematical terms clearly before you dive into solving extended responses. If the question asks you to evaluate the roots of y equals the modulus of f of x, make sure you conceptually define what happens at those roots. They aren't just random intercepts on a graph. They are the critical boundaries where the function's physical behavior radically shifts from original to reflected. You absolutely must use the correct vocabulary. Words like domain, range, asymptote, reflection, intercept, and vertex should be your absolute best friends. Creating a mental checklist for these exact terms can serve as an incredible memory hack when the exam pressure hits and your mind goes blank. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So, to bring this all together into an actionable game plan, whenever you face y equals f of x and y equals absolute value of f of x, I want you to lock this deconstruct, solve, evaluate loop deep into your brain. Here is the final system. These 3 rules guarantee top marks. Rule 1, command word decoding. Know exactly what the examiner is asking. Are you sketching, solving, or comparing? Rule 2, Peel framework application. Structure your analytical thinking so the examiner can't possibly deduct points. Rule 3, time management matrix. Spend your time exactly where the method marks are concentrated. If you follow this standardized sequence, deconstruct the question, extract the relevant data like roots and domains, select your analytical framework, and execute it with crystal clear notation, your mark potential literally jumps from 0 to 100%. You transform from an overwhelmed Sam or a confused Alex into a completely adaptable strategist. You flow like water. Before you ever hand in that exam paper, you must ask yourself this one fundamental question to guarantee you've maximized your true potential. Have you conceptually defined your terms, explicitly stated the domain boundaries, and rigorously shown all analytical workings to secure absolutely every possible method mark? Because that is how you ace Cambridge Math. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.